Good evening. Apologies for the lighting on this video. I am recording this at night and I just have a little lamp here. So I do apologize for the poor lighting and such. Today I wanted to go over the final schematic of the project itself. I've finally completed it. I added a bit more changes compared to last video, but I'd like to give a whole entire overview into what is actually going on. So the idea for this project was to make a template maker. I've never had template before and I just thought it'd be nice to do. I did this project as a learning exercise more so, but as well to try and make tempeh, as ridiculous as it sounds. But I think for these type of things, for learning, you just do whatever gets you going, whatever gets you excited. And for me, it was this. It's nothing revolutionary. It's nothing like saving the planet or whatever. But I wanted to learn more. This project does have a lot of incorporate. Has tons of hardware, tons of firmware that needs to be completed, PCB layout, mechanical, like 3D modeling, things like that. Because I'm going to make the enclosure and things. It incorporates a lot of elements, so it's quite perfect for a learning exercise. With the input power section, we start off here. I've got 6 batteries. I'm running a three series, 2 parallel. You got 3 battery series and 2 parallel connections. What this will do will give me the voltage and the current capabilities that I will need to run this, because heat does take out a lot. These heat pads, if you haven't been keeping up, which I believe you should, these heat pads here, got them off from Adafruit. They do take out an amp current at 12 volts, something like that. So I do want to keep running. Obviously, this thing is going to be turned off and on. Sorry. So got the batteries here. We have the BMS module. Of course, I would have loved to design this myself, but I just lack the knowledge and I haven't. I don't really know how to start off or make. I hadn't opened one around here. That's a tea bag. That's my FPGA. I'm just sorting through all my stuff. I do apologize. I have it right here. So I know the lighting is quite poor, so I do apologize. But I got this module off Amazon. It's just one of them BMS modules, if you could see that. Lots of components on there, so be MOSFETs and current sense resistors, I presume diodes, whatever. And it's to measure the voltage of each one and give the respective voltage and protection for what these batteries need. It's made for lithium ion specifically. Haven't tested this, so this will be testing it out. And this is a footprint, so I haven't made the footprint yet, sorry, but the schematic diagram, I'm going to solder these footprints down there, place the board on like that. That's what I'll do from there. Afterwards, we are heading into the power switch. As from the last video, I forgot to add a power switch, so the thing would keep running. It would be quite helpful to put one in, and unless I like pull out the barrel jack, the thing won't turn off. So power switch for the battery, turn it all off. It will not run, so that's always nice. And it's going through here. So this is a power switch IC. As you can see, it's got a sense portion here. So if a barrel jack is detected, this will be turned off. I believe this is an N channel or P. I always get mixed up. I think this is N channel. This N channel FET will turn off and nothing can run through. Oh no, this is P channel, isn't it? A quick Google search revealed that this is a P channel, so I need to remember that. And it makes sense because it's not connected to a ground, it's connected so it can allow the whole thing through. So this thing is naturally on, and then once this detects, this will send a gate. This will activate the gate, this will close off, and only this can run through. Got the coupling cap here and here. Test point here. Very important to add some test points. You'll be very grateful for your projects when you do add them. And if you forget them, you know. Moving on. We've got the VCC here. It goes into here. 24-volt boost converter. I did this, I think, for the ICs that I have chosen. Needed 24 volts, or I chose that as a rough in between. Going through some decoupling caps here through the switching inductor. More so. Just following standard, following the data sheet. Nothing too special. Nothing too special at all. We come out here at 24 volts. Nothing special at all. Wouldn't worry too much about it. So this one would mainly be shared between these two. But as you can see, you have two separate buck regulators here. So this is the 3v3 buck regulator. This will be used for the micro and all the other peripherals that require 3v3. Standard datasheet values, inserted it in, nothing too special. I've added some notes here. So if the thing works, if the on and off pin doesn't work, I can replace with a 0 ohm if need. So 1206, the size case, I don't know if there is, I should really check. But moving on. Again, test points whenever. Heat pad regulator. So I've got two ICs here. I've got this buck converter. I see if you may ask why I didn't use a buck boost converter as instead. I could have, I really could have, but I don't think it got the values I required. Or I wanted to use this because this is a new learning opportunity. This is a voltage programmer. Stick some current in the voltage feedback and you can adjust the output without the need to adjust the external. So usually your feedback resistors here to be connected to the feedback pin of this device over here. And depending on this R2 resistor, you get a different voltage, but you won't need to do that with this voltage programmer. This all does it for you, given you program the damn thing. So we got the variable voltages. We'll go to 1 to 12 volts because our heat pad can do so. And this is the two connectors we will connect our heat pad to in series. So the current will be the same. Theoretically anyway, I believe. Moving on, we got our microcontroller. We're using the STM32WB10CCU5. What a mouthful. So, why did I choose this chip? No particular reason. I'm only learning to do firmware and started to use the STM32s. Everyone is different really, but STM32s are fairly popular, so I could find tons of tutorials and books and whatnot to help me along. Again, fairly standard datasheet. I should really put the reference circuitry that I used, as that would be a good thing to do, ideally. And I'll see to that. Added a RGB LED and two switches for I/O purposes. I believe you'll need, I'm not too sure, but it's always better to have them. Per the last video I showed, I had these connected the wrong way around. I connected it to ground. 3v3 here and ground here. By connecting to ground, it eliminates the chance for false actuations because due to noise and whatever. So that's why, and this is probably the more correct way to put connectors on the same schematic anyway, because these things are going to be connected. It's good to have the note to what the connectors do. So you've got temperature sensor connector, programmer, and OLED display. As well, no J3 connector is for OLED. That's a bit redundant now, so I should really put it. J3 is not even the OLED. J3 is not even on here. Where is J3? J3 is the heat pad. Let us delete that, because that is wrong. Address for OLED display is 0x3C. This is its I2C address, and this is what you need to program it. So it's good to put the note there instead of me scouring through data sheets. I can refer back to here. Save yourself some time, and even in the workplace, it is good practice to put the address and such, I believe. At least I do anyway. Follow my example. Even though the channel is called Amateur Engineering, or Engineer, I don't remember now. Temperature sensor. Temperature sensor is to be connected to a separate board. I did this because, as per I explained in my last video, I say as per lot. I will put the board separate to the main board. So I might have the main board on top, the temperature sensor here. And I only wanted the temperature sensor to be kind of exposed, not the whole board, but we'll see about that. Don't know how much it affects temperature wise, but you know, it's ambient, it's like 25 to 30 we get in there, so I shouldn't be too worried. We will see about it. Honestly, we might not even need it in the end. I might just think like, oh, I'll just stick the whole thing on the bottom layer of the board, stick some screw terminals in, you know, and job's all fine. But maybe I don't want to do the bottom. Maybe I don't want to solder on the bottom too. But yes, that is all for this project schematic. Hope that explains everything. Again, these values here, standard data sheet, example circuit, reference circuit. Nothing too complex. Next step I think I'm quite excited for this. It's the layout. I do enjoy layout. I haven't even done a layout on KiCad before. Only ever used Altium and Easy EDA. I wanted to learn KiCad anyway. You know, it's a good free open source piece of software. I know I've said in the past videos like, oh, I hate KiCad, but that's just me being a dick and not knowing how to use it. Like I have the grid on 0.01. It should be on just a regular one like that. You know, why do you need a 0.01 grid? So yeah, future projects. So I'll be doing the layout for this and probably doing the firmware in parallel, or I might just do one at a time. We'll see about that. This project's been going on for maybe 2-3 months now, and it's just taking a while. I have like I said before, shiny object syndrome and just picking up new stuff. But I think I'm going to really crack down with this one. Future episodes will entail, or development logs, whatever you want to call this, is layout, firmware, and the actual building structure. So the actual assembly of the device, doing the soldering on it, or just literally applying solder paste and chucking it in an oven. We'll see how it goes. But that is all for now. Do take care.